this seminar, we want to practice the domain of definition and the range of a function and of its inverse. Consider the function arc cosine of 1 over x. First, let's find the domain of definition of this function. We have the fraction 1 over x, so x must be different from 0. The graph of 1 over x is easy to sketch. This is the hyperbola. And now what about cosine? Arc cosine. The function cosine must be restricted in the domain just to the interval from 0 to pi, so that it is injective, and only then the inverse exists. And the inverse is a graph that looks like that. As cosine produces values between -1 and 1, then arc cosine accepts x values, the inputs in the range -1, 1, in the interval -1, 1. And as cosine is defined in this restriction for 0 to pi, then the arc cosine gives results between 0 and pi. So for this expression to exist, the argument of arc cosine 1 over x must be not more than 1 and not less than -1. And the condition for x is easy to find from this graph. Here we have 1 over x, and here we have the values -1 and 1. We see that x may be large, then the fraction is small. But large means here in this part, that means at least 1. Or it may be large negative, that means this part of the graph, that means less than -1. So x must be greater than or equal to 1, or x must be less than or equal to -1. In other words, we can write that x must be from the union of these two intervals, from -infinity to -1, and -1 is accepted, so right closed, union from 1 to infinity. So this is the domain of the definition of the function f. And what about the range? If x is in this domain, then 1 over x will be easy to find from these points. For negative x, 1 over x is decreasing, so the maximum input results in the minimum output, and minimum input results in the maximum output. And 1 over -infinity is 0. Or we can say that we consider limit of 1 over x for x approaching -infinity, which is 0. And for positive x, 1 over x is also decreasing, so the largest input results in the least output, and vice versa. The minimal input results in the maximum output. And if we apply arc cosine to all these values, then arc cosine is again decreasing, so the maximum input results in the minimum output, and arc cosine of 0 is by half, and the minimum input results in the maximum output, and arc cosine of -1 is pi. This is round and this is square. Well, these two endpoints change the role, so we can sketch a little arrow to denote what generates which result. And the same is here. If the operation were increasing, then these two arrows were parallel, they wouldn't cross. And arc cosine of 0 gives pi half, and arc cosine of 1 gives 0. And as these numbers are greater than this, it will be better to write it in the reverse order. From 0 to pi half, union pi half pi. So this is the range of the function. And as the function f is injective, because it is a composition of injective functions, it has inverse, and this is the domain definition of the inverse. And similarly, as this was the domain of definition of the function f, so this is the range of f inverse. And what about the graph of f? Arc cosine of 1 over x. So we'll start here. If x is 1, 1 over x is 1, and arc cosine of 1 is 0. So we have 1 point on the graph of the function, 1, 0. As x increases, 1 over x goes to 0, and arc cosine increases up to pi half. One does belong to the domain, so this point does belong to the graph. And here we have the open bracket. Infinity is just a symbol, it's a number. So there is no endpoint of this branch of the graph. It approaches asymptotically the line y is pi half, but it has no endpoint. And what about negative x? If x is minus 1, then 1 over x is also minus 1. And arc cosine of minus 1 is pi. So this point, 0 pi, is part of the graph. When x decreases, when we go to the left, then 1 over x increases to 0. And we are here, arc cosine gives results that go down and approach pi half. So there is a common asymptote on the left, on the right and on the left, namely the horizontal line y is pi half. So that was the graph of the function. And the graph of the inverse can be constructed either by mirroring these two parts around this line. Sorry, there is one mistake. X goes from minus 1 to minus infinity, so it's like that. I'm sorry. For x values close to 0, the fraction would be too large, unacceptable for arc cosine. And if we, so this is 1 and minus 1, and this is 0 and pi. And if we take the mirror image range of that with respect to this line, then the point 1, 0 goes to 0, 1, and this asymptote, this vertical horizontal asymptote turns into a vertical asymptote, and the graph looks like that. And this branch, when reflected around this line, gives a branch like that. And this was called pi. The endpoint, minus 1 pi, comes to pi minus 1. And this part results in this part of the graph. So these two branches produce the graph of the function, and these two parts are the graph of the inverse. So that was the exercise how to work with composed function and how to find the range and the domain of definition and how to find the inverse. Well, what actually we have not yet found the inverse. So if we know that the function is injective, it has inverse, how to find the inverse? If we write the original function y is arc cosine of 1 over x, then we want to find x. We apply cosine to get rid of arc cosine, and we take the absolute value and we swap left and right. So x is 1 over cosine of y. So we can find the formula for the inverse f minus 1, and we call the argument x as usually. And this is this expression when we change x and y. So we have 1 over cosine of x. Note that if we call this the inverse to that function, then x must be only from this set, domain of f inverse, which is the union of these two intervals. Even though if we consider the natural domain of definition of this fraction, then it can be evaluated for many other values of x. But then this function would not be injective, and it must be injective if it is inverse to f, because then f is inverse to minus 1, so f minus 1 must be injective. So that was the exercise, how to find an inverse function and its range and its domain in terms of the range of the and the right